In the era of cloud computing, infrastructure as a code is becoming an essential part of software development lifecycle. Terraform is one such tool that enables us to write, plan, and create infrastructure resources in a declarative way. In this Terraform series, we will start from the basics and gradually move towards advanced topics. I am a full stack developer and a top rated plus freelancer at upwork.com. Also, if you have not subscribed my channel, you can subscribe now. It helps to create more courses and tutorials for free. So let's get started. In the first part of the series, we will cover an introduction to the Terraform and its key concepts. Terraform is an open source tool developed by HashiCorp written in a Go language. It allows you to define and manage your infrastructure as a code in a declarative language. Terraform supports multiple providers such as Amazon Web Services, Microsoft Azure, Google Cloud Platform, and many more. Terraform uses a declarative language called HashiCorp configuration language to define infrastructure resources. HCL is a human readable language that enables you to define resources and their configuration in a simple and concise manner. Key features of Terraform. Infrastructure as a code. Terraform allows you to define your infrastructure as code, which enables you to version and manage it like any other software code. Multi-cloud support. Terraform supports multi-cloud providers and services, enabling you to manage your infrastructure in a consistent and unified way. Declarative language. Terraform uses a declarative language to define infrastructure resources, which makes it easy to read, understand, and maintain. Plan and apply. Terraform provides a plan and apply workflow that allows you to preview the changes before applying them to the infrastructure. State management. Terraform maintains a state file that records the current state of infrastructure, which enables it to detect any changes and apply them only when necessary. Terraform has several key concepts that are important to understand before using it. Providers. Providers are the cloud service providers that Terraform supports. Terraform provides a plug-in architecture to support multiple providers. Resources. Resources are the individual components of your infrastructure that you define in a Terraform. For example, an EC2 instance in an AWS or a virtual machine in an Azure. Modules. Modules are reusable pieces of infrastructure that can be used to create complex infrastructure configurations. Modules can be shared and used across different projects. State. State is a file that records the current state of infrastructure. Terraform uses state to determine what changes to make when applying updates. Variables are used to pass values to Terraform configurations. Variables can be defined in a separate file or in a same file as a Terraform configuration. Outputs. Outputs are the values that are generated by Terraform configuration. Outputs can be used in other Terraform configuration or as an input to other tools. If you want to get started with Terraform, you need to follow some steps. First, you need to install Terraform. It can be installed on various platforms such as Windows, Mac OS, and Linux. You can download Terraform binary from the official website. As we will discuss this installation process in our next part. Then you have to choose a provider. Okay, it can be AWS, Azure, or Google Cloud provider. Then you have to write Terraform configuration in HCL that defines your infrastructure resources. Then second last, you have to run the plan command to preview the changes that Terraform will make. Then at the end, you have to use a run apply command to apply the changes to your infrastructure. So this was all about introduction and basic key concepts of Terraform. In our next part, we are going to discuss how to install and set up Terraform and AWS CLI. In the previous part of the Terraform series, we discussed the Terraform and its key features and concepts. In this part, we will discuss how to install and configure the AWS CLI and Terraform. Amazon Web Services is one of the most popular cloud providers, and Terraform supports AWS natively. The AWS CLI is a command line interface tool that provides access to the AWS services. So in this video, I will walk through the installation and configuration of AWS CLI and Terraform. Before we install Terraform and AWS CLI, we need to set up AWS account. Terraform can provision infrastructure across public cloud providers such as AWS, Azure, Google Cloud, and DigitalOcean, as well as private cloud and virtualization platforms such as OpenStack and VMware. So we are going to use AWS in our series. If you don't have already AWS account, head over to Amazon official website. Okay, you have to just sign up and you have to create your first AWS account if you don't have already. When you are done with your account creation, you have to just log in into your AWS account. So I am signed in using a root user. This user account has access permission to do absolutely anything in the account. So from a security perspective, it's not a good idea to use root user on a day-to-day basis. Okay, so what we have to do here, you will need to create IAM service. So what we have to do here, to create a more limited user account, you will need to use identity and access management, which is IAM service. Okay, so actually IAM service is where you manage users account as well as the permission for each user. To create a new IAM user, go to the IAM console. Okay, here you need to click on users. Okay, then you have to go to add users. Just give name to your IAM user. Okay, I will just give name CodeWithMuh. Next, then we have to attach policy here. Okay, we are going to give administrative access. Okay, I will just give administrative access here. Okay, and then we will just click on next and we can create a user here. So our IAM user is created. Now we have to get access key and secret key, because this secret key and access key will be used in our CLI when we will be using command line. Okay, So you have to just click on your username. Okay, here you need to go to security credentials. Okay, and here you need to create access key. You have to choose command line interface. Okay, next. Okay, now you can see you have access key and secret key. You can save these secret and access keys somewhere, so we will use this key later on in our videos. Okay, so I will just save these keys. The AWS CLI can be installed on Windows, Linux and Mac OS. So I will be discussing the installation process for each of these operating systems. For Windows, to install the AWS CLI on Windows, you have to just visit this URL. Okay, I will add this URL in my video description. Okay, so you can just visit this website of AWS. Okay, and then you have to click on Windows. Okay, here you need to download the AWS CLI MSI installer from the official AWS documentation site. Okay, so when you are done with the download, okay, then you have to start your installation. Okay, when the installation is complete, you can verify the AWS CLI is installed by opening a command prompt and running the command AWS variant. For Linux, to install the AWS CLI on Linux, you have to open your terminal window and you have to install Python package manager and pip by running a command sudo apt get install python pip. Then you have to install the AWS CLI by running command sudo pip install AWS CLI. After the installation is complete, you can verify the AWS CLI is installed by running the following command AWS variant. For Mac OS, to install the AWS CLI on Mac OS, you have to first open your terminal window, then you have to run command brew install AWS CLI. So it will install the latest version of AWS CLI on your system. So AWS CLI is being installed on my system. So it will take only few minutes to get ready. Alright, our AWS CLI is installed. Now we need to confirm our installation. For this, we need to run command AWS, okay, and variant. It will confirm which variant of AWS CLI is installed on my system, which is 2.11.0. Okay, next we have to do to configure AWS. For this, run the command AWS configure. Okay, it will ask you to provide your access key and secret key, and you have already copied earlier in this video. Okay, so use the access key and secret key so you can configure AWS. Just paste your key and enter, then it will ask you to add secret key as well. Alright, so I will delete these keys because I'm using for the testing purpose, so you don't need to share these keys with anyone because then your AWS account will be exposed. Okay, here you can skip. If you want to change your default region, you can enter the region name, but I will just go with the default, so I will just keep it simple. Enter. Okay, okay, so my AWS is now configured. So when you are done with your AWS configurations, okay, so then you can use it to interact with AWS services. Installing Terraform. Know that we have installed and configured the AWS CLI we can move to installing Terraform. Terraform can be installed on Windows, Linux and Mac OS. Okay, so now we are going to discuss how to install, okay, on each operating system. For example, if we have a Windows, okay, we have to just visit this Terraform official website. Okay, if you have Mac OS, Windows, okay, so you have to just download zip files, okay, archives, okay, and then you have to just execute these files. Okay, so as I'm using Mac, what I will do here, I will just copy this first command, okay, and I will run this command in my Mac OS. Okay, then I will just copy the next command so I can install Terraform. Okay, it's very simple and straightforward to install Terraform on your system. Okay, so Terraform is being installed on my system, so you have to just wait for it. It will take only 1 to 2 minutes to get Terraform installed on your system. Alright, Terraform is installed. Now let's check the version of Terraform, so we can confirm our Terraform installation easily. For this, you have to just run this command Terraform version. Okay, so it will tell you your Terraform version if your Terraform installation was successful. Okay, so you can see 1.4.5. okay, this version is installed on my system. So in the next part of this Terraform series, we will discuss how to create your first Terraform configuration file and deploy it to AWS. In the previous parts of this Terraform series, we discussed Terraform and its key features and concepts. And we also walked through the installation and configuration of AWS CLI and Terraform. In this part, we will create our first Terraform configuration file and deploy it to AWS. Terraform uses configuration files to define the desired state of your infrastructure. These configuration files are written in the HashiCorp configuration language or a JSON. Okay, so in this video, we will use HCL to write our configuration files. For this, you have to just open your text editor, or you can open your Visual Studio Code. Okay, and here you can create a folder for your project. Okay, first of all, you have to create a file. Okay, and you can give name to this main.tf, which is extension for Terraform files. Okay, so in this case, we have now created a Terraform file which is main.tf. Okay, now here we will write some code to define our infrastructure. First of all, what we have to do here, we need to define the provider. Okay, we are going to use AWS as a provider. Okay, so that's why I will first define provider. Okay, then I will define region. Okay, so we are going to use US East 1. Okay, then we have to define resource AWS instance, because we are going to create AWS instance. Okay, and here you need to give a name, for example CodeWithMuh, or you can give example, anything you can write here. Okay, and here you need to write the AMI, okay, for your EC2 instance, because we are going to create EC2 instance, and here we need to define AMI, okay, for our instance. Okay, then we will define instance type. Okay, so here two things we need to define. You can make sure your code is correct. Okay, all right, everything is fine now. So now let's discuss what can be the AMI, how you can find the AMI. Okay, So for this you can just visit a website, okay, this website, to locate AMI. Okay, as we are going to use US East 1 region, so in this region I will find AMI for my instance. For example, I will first select the region here, okay, then I have to choose the machine variant. Okay, I will go with 22.04 long-term support. Okay, then here you can see in this region, okay, with this configuration we have two available machines. Okay, what I will do here, I will just copy the AMI. Okay, for this I can just reduce the size of screen. Okay, I will just copy it. Okay, and I will go to my code and I will paste the AMI here, and here we need to define the instance type. As we are going to use this tutorial for testing purpose, I will go with T2 micro. Okay, and you can also go with T2 medium or small, any other instance type, depends upon your needs. Okay, so in this video we will use T2 micro. Okay, so now we have defined AWS, okay, provider and resource. So now let me explain you this file again. This configuration file defines an AWS provider and AWS instance resource. The provider block defines the AWS provider and specifies the region where the resources will be created. In this example, we are using US East region. The resource block defines an AWS instance resource and specifies the AMI, Amazon Machine Image, and instance type. So in this example, we are going to use this AMI, okay, and T2 micro instance type. Alright, so now we are done with our code for our configuration file. Then you have to just open your terminal of Visual Studio Code. Okay, then you have to perform few things here. What we are going to do here, we are just going to run command Terraform init. Okay, so it will initialize the Terraform working directory. Okay, so just run this command. This command will download the necessary provider plugins and initialize the working directory. You will see the changes here when the plugins and initialize directory will be ready. Alright, so you can see Terraform has been successfully initialized. Okay, so you can see these files are created. Next we have to run a command Terraform plan. So to preview the changes that Terraform will make by running the following command, okay, so it will tell us which changes it is going to do, okay, on our AWS. Okay, so it will show you in the terminal. Okay, so what is written in this code and what will be it will be doing. Okay, so if you check, okay, you can see when we will apply these changes, so these things will happen. Okay, so you can confirm before applying. Okay, next we can also run Terraform validate command to make sure the code written in Terraform is correct and the configurations are fine. Okay, so for this you can just run the command Terraform validate as well. Okay, I will just run this command Terraform validate. It will give us success message if the configuration are fine. Okay, it's mean everything is fine. So what we have to do here next to apply changes to your infrastructure, okay, so we can use a command Terraform apply. On running this command, okay, This command will create resources defined in our main.tf file. It will prompt just enter yes for the configuration, because after you enter yes, it will create all the resources in your AWS account. Okay, so you can just hit enter. So it will start creating all the resources defined in your main.tf file. So wait, it will take only few seconds to get ready your infrastructure on AWS. So you can see in the command, it is creating all the required infrastructure resources which we have defined in main.tf file. So after the changes have been applied, Terraform will output the details of the created resources, including the instance ID and public IP addresses. Okay, so now we are done. So here what we have to do, we have to confirm that these resources are created or not. To verify your infrastructure has been deployed correctly, you have to open your AWS account, okay, and go to your EC2 management console. Okay, just open EC2 dashboard and make sure you are in the same region so you can confirm your EC2 instance is created or not. Here you can see our EC2 instance. Okay, so we can just wait here. Okay, I will just click on instances. It will take me to the AWS dashboard. So you can see our T2 micro instance is created. Okay, so one thing you noticed here, the name is missing. Okay, what we can do here, we can add the name as well. Okay, we can update our script. Okay, so it will add the name here in our instance as well. Okay, as we don't have the name of our EC2 instance, what we can do here, you have to just add the name for your EC2 instance. You can use tags here. Okay, and here you need to define the name of EC2 instance. I will just give name CodeWithMuh. Okay, so you can see here we have updated our script. Okay, all right, so now you have to just open your terminal again. Okay, and then here what we will do, we will apply the changes. Okay, so it's a best practice, before you apply changes, make sure to validate and check the plan. So it will tells you which new changes it is going to update. So just run command Terraform plan. It will tells you what necessary updates are being taken when we will run Terraform apply. Okay, so you can see here the tag which is CodeWithMuh is being added. Okay, only one change. So I will just do here, I will run command Terraform validate. Okay, first to validate if everything is fine. Okay, so it's a good practice to validate everything before you run command Terraform apply. Okay, all is good. So I will just run command Terraform apply. Okay, so it will assign a name to our EC2 instance. All right, hit enter. Yes. So it is modifying our AWS instance. Okay, it is updated. Now just go to your console AWS, just refresh it, you will see the name here. Alright, so we have created our first Terraform configuration file and deployed it to AWS. We use AWS instance resource to create an EC2 instance. in the US East region. Terraform enables you to define your infrastructure as code, which makes it easier to version, review, and collaborate on changes to your infrastructure. With Terraform, you can easily create, modify, and delete infrastructure resources, and you can do it all with a few simple commands. So, as we know, this is for testing purpose. If you're also doing it for the testing purpose, you can destroy your resources using a Terraform command, Terraform destroy. Okay, so you can avoid unnecessary charges on AWS, okay, if it's just for a testing purpose. So don't forget to destroy your resources. Okay, so just run the command Terraform destroy. Okay, so it will destroy all the resources that you have created. Yes, for the confirmation of deletion. So it's destroying our AWS instance. So if you can check on your AWS, you can just refresh it. You will see the instance state termination is in start, termination in process. Okay, so you can see our instance is being terminated. Okay. All right, good. So we are done with this part. All right, so in the next part of the Terraform series, we will discuss how to use Terraform to create more complex infrastructure. In this video, we will be discussing the fourth part of the Terraform series, where we will be creating a VPC with a subnet, security group, and EC2 instance. We will create an Amazon virtual private cloud with a subnet, internet gateway, and custom route table using Terraform. We will then create an elastic network interface and associate an elastic IP address with it. We will also create a security group to allow ports 22, 80, and 443. Finally, we will create an EC2 instance and install Apache on it. By the end of this video, you will have solid understanding of creating a VPC with subnet, security group, and EC2 instance using Terraform. Let's begin by discussing the project outline. First of all, we will create a VPC, then we will create internet gateway. At the third, we will create custom route table. At fourth, we will create a subnet. At 5, we will associate subnet with route table. At number 6, we will create security group to allow ports 22, 80, and 443. At number 7, we will assign ENI with IP. At number 8, we will assign elastic IP to ENI. At number 9, we will create IAM role to access S3. At number 10, we will create Linux server and install and enable Apache on it. At the end, at point 11, we will enable VCP endpoint. Before we start creating the infrastructure, we need to set up the environment. We will be using the AWS provider for Terraform to create the infrastructure in AWS. The first step is to create the directory and initialize it with Terraform. So let's get started. First of all, you have to create a folder, and you can open the folder in Visual Studio Code. Okay, and then you have to create a file main.tf. Okay, this is our Terraform file where we will write our Terraform code. Okay, and then we have to define our provider as we are going to use AWS provider, okay, so we will define our provider first, okay, and the region we are going to use for our configurations. Okay, so we are going to use US East 1 in this video. Alright, so this code configures the AWS provider for Terraform and sets the region to US East 1. So now let's move to the point 1, which is creating a VPC. Let's define a resource. The resource name will be AWS VPC okay, and here we need to define CIDR block and we need to assign an IP and then we have to define tags to assign a name CodeWithMuh. Alright, so this is our resource of VPC. Alright, no, it's fine. So here we created a VPC with CIDR block and we also added a tag with the name CodeWithMuh to identify the VPC. Alright, so next we need to create internet gateway. For this I will just write creating an internet gateway. Okay, let me create some space for this option 2. Okay, here we are going to create an internet gateway to allow our VPC to communicate with internet. We will use the AWS internet gateway resource for this. Okay, so let's create a resource here, AWS internet gateway GW CodeWithMuh. You can also give any other name as well. Alright, so let's define some properties here. VPC ID we have to give, okay, AWS VPC .a.id. okay, so because we are using the VPC we have created earlier, okay, so I have given the name we have created earlier. Okay, so this is our internet gateway. So here we need to assign a name. Okay, for this we can add a tag here, okay, and we can assign a name to this internet gateway. I can give a name internet gateway CodeWithMuh. Okay, so this is our internet gateway resource. Okay, so we have just created an internet gateway and associated with a VPC we created earlier. We also added a tag to identify the internet gateway. After creating the VPC and internet gateway, we can create a custom route table to specify how traffic should be routed between the VPC and internet. In this case, we want to route all internet bound traffic through the internet gateway we just created. To create a custom route table in Terraform, we use the AWS route table resource. We specify the VPC ID using VPC ID attribute, and then we define a default route to define internet gateway using route block. So let's create resource for our AWS route table. So this will be our number 3 resource we are going to create here, which is to create a route table. Here we need to create a resource, and resource name will be route table, and name resource table CodeWithMuh. Alright. No, here we need to define some attributes. VPC ID, which we have already created. I will just give name AWS vpc.a.id. okay. Next we need to assign a route. Okay, for this just create a route here, CID or blog, so we can write an IP address so it can access. Alright, so make sure your syntax is correct. Next we have to define gateway ID as well. AWS Internet gateway dot gateway name CodeWithMuh. Alright, so we have now assigned two things in our route, CID or block, okay, and we have also defined gateway ID as well. Okay, so we are now done with our route. Next we need to create another route as well, and here we can assign IPv6 block, and we can assign here. Alright, next we have to assign gateway ID AWS Internet Gateway dot GW CodeWithMuh, the name of internet gateway we created earlier, CodeWithMuh dot ID. Okay, so we have created two routes here. Okay, make sure we don't need to add quotations here. Okay, alright, so next we have to add tag so we can give name to our route table. Okay, so the name will be for our route table. I can give name tags. We can add tag to give name. Okay, so it will be route table CodeWithMuh. Alright, so now we have defined our route table as well. Okay, so now we are done with our route table. Here we have just created a AWS route table resource and named it route table CodeWithMuh. We set the VPC ID attribute to the ID of the VPC we created earlier using AWS VPC ID. Next we defined a route to the internet gateway using route block. We specify a CID or block of 0.0.0, okay, so which matches all IP addresses, and set the gateway ID attribute to the ID of internet gateway we created earlier using AWS Internet Gateway. Finally, we added a tag block to resource to give it a descriptive name. Okay, so next we need to move to our resource number 4. Okay, we are going to create a subnet. Creating a subnet. Know that we have a VPC and a route table. We can create a subnet for our resources. In this case, we want to create a subnet in the US East 1A availability zone with a CIDR block. Okay, to create subnet in Terraform, we use AWS subnet resource. Okay, we specify the VPC ID using VPC ID attribute, the CIDR block using CIDR block attribute, and the availability zone using the availability zone using the availability zone attributes. Now let's define our resource. Okay, so we can create a subnet here. For this, we can just create a resource AWS subnet and name subnet CodeWithMuh. Okay, so here we need to first check VPC ID. VPC ID we have already AWS VPC VPC dot a dot ID. Okay, and next we have to create another attribute which is CIDR block, and here we need to assign an IP. Okay, so next we have to define availability zone. We are going to use US East 1A. Okay, then we have to add another attribute which is depends on AWS Internet Gateway dot gateway name CodeWithMuh. Okay, next we have to add a tag. Subnet CodeWithMuh. So this is our resource number 4 where we have created a subnet. We set the VPC ID attribute to the ID of the VPC we created earlier using AWS VPC ID, and the CIDR block attribute to this IP address, and the availability zone attribute to US East 1A. We also set the depends on attribute to the internet gateway resource to ensure that the subnet is created after the internet gateway. Finally, we added a tag block to resource to give it a descriptive name. Next, we are going to create. Next, we have to associate subnet with route table. So this will be our number 5 resource. So this will be our number 5 resource. Associate subnet with route table. Give me a space. Okay, so let's define the resource. To associate the subnet with route table, we will use the AWS route table association resource. In the code, we have already created subnet and route table. We will just use their IDs to create the association. Okay, and then following Okay, now let's write down the resource here. Okay, and resource will be AWS route table association and the name RT2 subnet. We need to make sure the names are correct. Okay, next we have to write some attributes. Subnet ID we have already created, which is AWS subnet dot subnet CodeWithMuh dot ID. We have already created the subnet, so we are using the same ID we have created earlier in this code. Okay, so next we have to define another attribute, which is route table ID. And here what we need to do, AWS route table dot RT CodeWithMuh. Okay, so now we have assigned the ID of route table as well. So here we created a new resource called AWS route table association, and we assigned the subnet ID and route table ID to the route table ID. Okay, and this will create association between subnet and the route table. Okay, so now we are done with our resource number 5. Next we have a resource number 6. We will create a security group to allow ports 22, 80 and 443. Okay, so here we need to create this security group. Let's define the resource here. AWS security group. All right, and a name we can give short name SG CodeWithMuh. Okay, so then we have to give a name here, SG CodeWithMuh. Next we have to assign a description as well. We can write anything, allow SSH, HTTP, HTTPS, okay, inbound traffic, because 22 will be used for SSH, 80 will be used for HTTP, and 443 will be used for HTTPS. Okay, so next we have to assign VPC ID. We have already created AWS VPC dot a dot ID. Okay, next we need to define some ingress. Okay, so let's write first ingress, description, HTTPS from VPC. Okay, and here we need to define from port 443, okay, to port 443. Okay, and next we have to create another attribute, which is protocol TCP. Okay, then we have to assign another attribute CIDR block. It will be CIDR blocks. All right. Okay, and we have to here write the IP 0.0.0. okay, so this is our first ingress we have defined. So here next we have to define for HTTP and also for the SSH as well. Okay, so what I can do here, I can just copy this one and paste below. Okay, I can use HTTP here and the port 80. Okay, we need to remove 4 here. Okay, no, it's fine. And here we need to also write port 80. Okay, this is also TCP. Okay, fine. Okay, next we need to just copy it again. Okay, and we need to just paste it. Okay, and then we have to define SSH from VPC. Okay, this is for the port 22. Okay, got it. Okay, so now we have defined all these 3 ingress for inbound traffic. Okay, at the end we have to define another which is egress. Okay, from port 0, okay, to port protocol. It will be -1 CIDR blocks. Okay, now here we need to just make sure to add the IP. Alright, so our egress is also ready. Next we need to just assign a tag to our security group. Okay, which will be name SG CodeWithMuh. Alright, so this is our security group we have created here. If I can show you here, you can see this is our security group we have created. Okay, so here we are using AWS security group resource to create a security group named SG CodeWithMuh. We are providing the name prefix for the security group along with the VPC ID of the VPC we created earlier. Okay, then we are also defining ingress rules to allow traffic on ports 22 for SSH. Okay, for port 443 for HTTPS and for port 80 for HTTP. Okay, and also we have defined egress rules to allow all outbound traffic as well. Okay, finally we have added a tag to the security group for easy identification. Okay, alright, so now we are done with our resource number 6. Next we are going to create resource number 7. We are going to assign ENI with IP. We are going to assign Elastic Network Interface with IP. Okay, so let's create a resource AWS Network Interface ENI A. Okay, so this will be the name. Next we have to assign subnet ID AWS subnet dot subnet CodeWithMuh dot id. Okay, so we have already created this subnet, so we are using the same subnet here. Next, we need to define another attribute, which is private IPs. We can define here 10.00, okay, and add then 10. Okay, no, it's fine. Next, we have to assign security groups. AWS security group dot sg. The name of security group we have created earlier, CodeWithMuh.id. Okay, so here we have created a ENI, elastic network interface, with a specified private IP address in the subnet identified by the resource AWS subnet CodeWithMuh. Okay, then we have associated the elastic network interface with the security group. Okay, so now we are done with our resource number 7. Next, we have to create resource number 8. Here we are going to assign elastic IP to the elastic interface network. We are going to assign elastic IP to the elastic network interface. Assign elastic IP to ENI. Let's define resource AWS elastic IP, and the name elastic IP, I will give name A. Here we need to define first attribute VPC, okay, which is equal to true. Okay, next we have to define network interface, which will be AWS network interface. Okay, here we need to assign internet network interface we have already created. Okay, so I have assigned the ID. Okay, next we have to create association with private IP attribute, association with private IP. Okay, where we can just assign 10.0.10. okay, next we have to create another attribute depends on. Here we need to add AWS internet gateway dot sg, the name of internet gateway. Okay, so it is GW CodeWithMuh. Okay, and the ID. Okay, next we have to also assign AWS instance dot the instance name. Okay, so here we have just created few attributes in this resource. Okay, next we have to create tag. Okay, so we can give name to our elastic IP. I will just give name tags name elastic IP. Okay, done. So what we did here in this resource, we have created an elastic IP address and associated with the ENI identified by the resource AWS network interface. Then we have associates the elastic IP address with the private IP address, okay, on this ENI. Then we have specified the elastic IP address, okay, which is associated with the VPC. Also, we have added a tag, okay, for this elastic IP address with the name EIPA, okay. And also we have added depends on attributes, okay, with AWS instance and internet gateway, okay. So now we are done with our elastic IP resource number 8, okay. Next we are going to our resource number 9. We are going to create IAM role to access S3, okay. So this is our resource number 9. For this role, okay, you have to just copy a code because this role is little bit lengthy, okay, so we can save time here, okay. So I will just copy and paste the IAM role resource here, okay, and I will explain you. Okay, so now I have added a resource, okay. Here you can see this is all the code of our resource number 9, okay. So what I have did here, let me explain you, okay. First of all, we have created an IAM role named EC2 S3, okay, with the trust policy that allow EC2 instance to assume that role, okay. And we have created an instance profile named EC2 S3 profile, okay, and associate it with the IAM role created by resource AWS IAM role EC2 S3, okay. And then we have created an IAM policy named test policy and associated with the IAM role created by the resource IAM role EC2 S3, okay. And then we have grant some permission to perform all the action, okay, on S3, okay. So using this syntax, okay. So now we are done with our role. So now we are done with our resource number 9, okay. Now let's move to our resource number 10. In resource number 10, we are going to use to create an Linux server, and we will install and enable Apache 2. When our EC2 will be launched, automatically Apache will be enabled on our Linux instance, okay. So we need to create Linux server and install enable Apache 2, okay. So what I can do here, I can also just copy and paste the code I have already written, okay. So you can then just copy it, okay. Okay, so this is our resource AWS instance. Here we are creating an EC2 instance using Amazon Linux AMI, okay. And we have set the instance type to the T2 micro. And then we have specifies the availability zone to launch the instance in US East 1A, okay. Then we have specifies the key pair to use for SSH access. I have given name CodeWithMuh, okay. We will create this key pair before we apply the changes, okay. Then we have created an IAM instance profile, okay. And then we have specified the IAM instance profile created in our resource 9, okay. Then we have associates the instance with the network interface created in resource 7, okay. Then we have defined some user data script to install and enable Apache and start the Apache server and sync the contents of S3 bucket to the Apache document root directory, okay. And then at the end we have just defined a tag for instance with the name CodeWithMuh 1.0, okay. So this was our resource number 10. So now we have last resource, which is resource number 11. Resource number 11, okay, which is our last one resource, enable VPC endpoint Okay, so here we can define resource AWS VPC endpoint S3, and we need to just define some attributes here: VPC ID, AWS VPC .a.id. We have already created this VPC. Okay, so I have just defined the attribute VPC ID. Then we have to assign another attribute which is service name. Okay, and here we can define com.amazonaws.us east 1.s3. okay, so this is our service name we have defined here. Okay, next we have to just write down the tags to assign a name. Okay, test, I will just give name to this, a test. Okay, so all right, now we are done with our all the resources. Okay, now let me just explain this last resource. Here we have created an S3 VPC endpoint in the VPC created in the resource number 2. Then we have specified the service name for the S3 endpoint, okay, with this name. Okay, and then we have just set a tag for the endpoint with the name test. Okay, so these are all our resources. Okay, so what we have to do now here, we need to just confirm that our code is correct, we have any mistake or not, all things are correct. So we can just double check here. Okay, so first of all we have created AWS, okay, as a provider. Then we have created a VPC. Okay, this is also fine. And then we have created an internet gateway. Okay, so this is fine. Next we have created a route table, okay, which is also looks fine. And at the end we have created a subnet resource. Okay, and then we have just created resource number 6, which is a security group. Okay, and here we need and here we did a mistake. Here we need to just make sure our syntax is correct. Okay, we need to assign this operator. Okay, all right. Okay, so it is a good practice to confirm everything is fine. Okay, so all other resources are fine. Okay, so now we are just done. What we have to just open our terminal now. Okay, we have to just move to our folder. Okay, my folder name is part 4. I will just move to this folder 04. Okay, so here we need to just first of all do initialization. Okay, so before we apply infrastructure, we need to create a key pair, okay, which we have defined in our point number 10. Okay, if you look into this, for example, if I go into the point number 10, you can see we have a key pair named CodeWithMuh, but we have not created this key pair in our AWS account. First of all, we need to just create this. So for this we have to run a command so we can create our key pair. For this you have to just run command AWS EC2 create key pair key name Okay, so here we need to define our key name. So we have already written the key name CodeWithMuh. So what I will do here, I will just keep the same name here. For example, if you go above, okay, our key name is CodeWithMuh. Okay, so C is capital, so I will just write it again, CodeWithMuh. Okay, so make sure your key name is correct. Okay, so CodeWithMuh and query. Next we have to here key material. Okay, and then we have output output text, and then we have to again write our key pair name CodeWithMuh.pim. So in this format the file will be downloaded. So actually this is the command which will create key pair, okay, with the name CodeWithMuh. Okay, so this query will be applied and our key pair will be downloaded. Okay, so just double check your syntax is correct. Okay, so what I will do here, I will just hit enter, so our key pair will be downloaded. Okay, so just let me just hit enter, so you will see the key pair is downloaded here. Okay, it's a good practice to do and create key pair in this way. Alright, so we are done with our key pair. Okay, next we have to just initialize our Terraform project. Okay, what I will do here, I will just write Terraform init. Okay, so it will create some necessary folders, file structure, okay, plugins. So our Terraform project will be initialized. Okay, so our initialization is done. Okay, next we have to just validate that our code, everything is fine or not. For this we can just run command terraform validate. Okay, so it will give us, okay, you can see here we did some mistakes. Okay, so it will tells us where we have issues in our code. Okay, it's a best practice to do Terraform validate. Okay, so it will tells if we have some mistakes in our code lines. Okay, so we can fix before applying. Okay, so here you can see at line number 41, line number 1 to 4 and line number 2 to 4 we have some mistakes. Then how we can fix these mistakes? We have to just first go to the line number 41. We have issue all the in our tags line. Okay, so let's fix these issues now. If I just go to line number 41 first. Okay, this is our line number 41. So you can see we have forget to add equal sign. Okay, next we have the issue in our line number 124. Okay, we have reference to undeclared resource. Okay, if we go to this line number 141, line number 124. Okay, and also on the line number 20 we have also the same issue. We can fix the issue first, this one. First of all, line number 220. Okay, yeah, here you can see, so we can just fix it. So it's a good practice to validate resources if any issue happened in your code. Okay, so we have no last issue we need to fix at line number 1 to 4. So we have to just open line number 1 to 4. Okay, so here we are getting an issue, so we need to first check where is the issue. Okay, if you check, we have the mistake here, network. Okay, the spells are not correct. Okay, so no, it's fine. So now we have fixed all these issues. Now let's validate it again. So we will see if any success message, it's mean our code is fine. Okay, still we have the issues on line number 125 and 128. Now let's move to the line number 125 and 128. Okay, here we need to add tags as well. Okay, and line number 125. Okay, if we just move to line number 125, we can see here we have a mistake, association with private IP. Okay, so we have issue here. We need to just make sure our attribute name is correct. Actually the name is associate. Okay, not association. Okay, so associate with private IP. Okay, so now we have also fixed these two bugs as well. Now let's me validate it again. Okay, now you can see our code is fine and we have received the success message. Okay, so And that's why I have made some mistake to show you how to validate your code before making any changes and applying. Okay, so next we have to run command terraform plan. So this command will tells us which things you are going to create on your AWS. Okay, so it's a good practice to run the command to see which things we are going to add. Okay, 13 things we are going to add. Okay, all the security group and everything. Okay, you can see the list is provided here. Okay, so what is going to be created in our AWS. Okay, so all is fine. Now let's apply changes. What I will do here, terraform apply. Okay, the syntax is not correct. Terraform. Okay, apply. So it will ask us to give permission to create resources on AWS. Yes, so it will create resources on the AWS. Okay, like EC2, S3, all the resources. So all the resources are being created. When all the resources will be created, we will just open our AWS to verify the resources are created or not. Okay, this is my AWS account. I will just go to EC2. We can check if our EC2 is created or not. You can see our EC2 instance is being initialized. Okay, so this is our EC2 instance we have created in our point number 10. Also you can see all the resources are created, which is a great thing. Okay, and also if you can see here at point number 10 we have the Linux server, which is CodeWithMuh. Okay, so this instance is also created. Okay, because the name of our instance name is CodeWithMuh 1.0. so if you just edit it, you can see the correct name. Okay, so similar all the resources are also created. Also if you check the security group, we have given name the security group SC CodeWithMuh. It is also created. Okay, so it's very easy to create resources and create infrastructure. Okay, using AWS. Okay, so what we have to do here, because it was a testing purpose. Okay, if you are also doing it for testing purpose, you can delete all the resources. Okay, because otherwise it will charge you extra. Okay, I will just delete terraform destroy. Okay, so it will destroy my all resources that I have created on AWS. Okay, okay, all the list of resources which are going to be deleted are being listed. Okay, so we need to permission. Yes, so all the resources will be deleted. So in this part of our Terraform series, we have successfully created a VPC and configured various resources within it using the Terraform infrastructure as a code tool. The resources created include an internet gateway, a custom route table, a subnet, a security group to allow inbound traffic on ports 2280 and 443, an elastic network interface with a private IP address, an elastic IP associated with ENI, and an IAM role for accessing Amazon S3. Additionally, we have installed and enabled Apache on a Linux server and enabled a VPC endpoint. The use of Terraform enables us to automate the deployment and management of infrastructure resources, allowing us to provision resources quickly and efficiently. The project provides an excellent example of how Terraform can be used to build, manage, and update infrastructure resources in an organized and scalable way. Alright, so this was all about our project. Don't forget to like, share, and subscribe my YouTube channel. If you have any questions or feedback, leave a comment below. I will get back to you. Stay tuned for more courses and tutorials. And until next time, goodbye.